right, welcome once again. Today we'll be talking about an aspect of physics known as introduction. I want you to understand that observation of electrical attraction can be dated back to the times of the ancient Greeks. Ancient, ancient Greeks. They started up the work. Ancient Greeks. So, and the first person we are considering is Thales of Miletus. Of Miletus in the year 640 to 540 BC. So what is his observation? He observed that a body could be made attractive by rubbing. That is a wonderful observation. He said that a body could be could be made attractive by rubbing the body. That's rubbing two bodies to make them attractive. Rubbing two bodies to made them attractive. So, after him making this wonderful observation, Tell and others discovered that amber, 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 after when it had been rubbed, can stand a chance of attracting other objects such as feather. Amber, after when it has been rubbed, can stand a chance of attracting other subjects such as feather. That's why some of us did this experiment of using your biro pen to generate these forces in your secondary school. After that, you bring it towards a tiny piece of paper and it will be attracted. All right. So amber, after when it has been rubbed, can be what? Can attract tiny objects such as feather. Then you see there is another man in the person of William Gibbard, an Englishman, Gibbard, William Gibbard, in 1700. William Gibbard discovered that this electrical phenomenon of rubbing two bodies to generate forces is not just limited to amber, but it's a general phenomenon. He says it's not just limited to amber, but other things can also be made attractive by rubbing, such as plastic rods, such as plastic rod and what you call ebonite and four, or grass rod and silk. We're going to be looking into that. So it's the other subjects can also be made attractive by rubbing. That is this wonderful discovery. Then you see for him saying this, scientists and many scientists went ahead in electrifying as many objects as possible, including humans. So that is after William Gibbard said that it's not just limited to amber, but what? A general phenomenon. Then we talk about, in 19th century, scientists made a whole lot of discovery about the similarities between electricity and magnetism. Not only that, we talk about Hans Ørsted in 1820. Hans Ørsted, what is on discovery? Hans Ørsted discovered that um, a compass needle, which is magnetic in nature, could be deflected in the presence of an electric field. If you press a compass needle in an electric field, it will what? To be deflected. That is its own discovery. All right. And I want you to understand that all these electrical phenomena are attributed to what we call static ring. You can see the name as I say electrostatic. So all this electrical phenomenon can be attributed to what? Static ring. And what is static ring? It is an electrical phenomenon that accompanies dry weather. Static ring is an electrical phenomenon that accompanies dry weather. And that is why when our clothes is able to stick to our body, and not only that, when you iron a piece of paper and bring it close to television screen, it will get attracted. So that is it. And even a piece of paper sticking together to each other is all by this static ring. Not only that, you also talk about comb. When you comb your hair and bring the comb towards a tiny piece, something like a tiny piece of paper, it will also get attracted. All of them is under the subject matter of static ring, which is electrical phenomenon that accompanies dry weather. It is an
All right, like I said, all this wonderful discovery. Remember, Tell did this in the 640 to 540 BC. Then after Tell discovered that a body can actually attract another body after rubbing, and they use him and others, Tell and other scientists use amber. You see it, amber. That's what they use. Amber, I said that amber can attract tiny piece such as feather after it has been rubbed with other bodies. You see it now, amber can attract. Then remember, this amber under normal circumstance cannot attract anything except if it is being what? Rubbed. So that rubbing is a way of what? Electrifying it. So with this, a body made attractive, a body made attractive by rubbing is said to be electrified. Said to be electrified. Is said to be electrified. A body made attractive by rubbing is said to be electrified. Like I said, you see another scientist, William, saying that this is not just limited to amber, but what? A general phenomenon. Then you see similarities between electricity and magnetism, and then you see that's in 19th century, and you see the work of Van Orsted. He said that he used what we call compass needle, and compass needle is magnetic in nature. But when you press it in an electric field, you see it diffracting. So that diffraction showed that something have actually happened. So that means there's a whole lot to learn under electricity. Of course, we talk about static grid. I told you it's a phenomenon that accompany electrical phenomenon that accompanies what we call the dry weather. And I'll give you instances on that. Even when you iron your clothes and put it on, it's still as if it is pulling or attracting your hair, the hairs on your body and all that. So these are the observations that we make in our day-to-day activities. So I want us to talk about electrostatic. What is electrostatic? Electrostatics. Electrostatics. Electrostatic is no other thing than the study of the charges and charge system at rest. Charges and charge system at rest. You can see electron meaning electron and static, electron standby and all that. So it is like when we say electrostatic, it is the opposite of what is known as current electricity, which study charges in motion. So electrostatic is the study of charges and charge system at rest. Or simply put, it is the study of what? Charges. It is the study of electrical charges. Electrical charges at rest. Now, because of that, what is this charge? What is charge? What is charge? What is charge? Let's say one or two things about charge. Charge is no other thing than accumulation of electron or deficiency of electron. Charge is accumulation of electron or deficiency of electron. You can also put it that charge is a material obtained as a result of electron imbalance in an object. It is a material obtained as a result of what? Electron imbalance in an object. It's very important. Charge is a material obtained as a result of what? Electron imbalance in an object. Remember, when we talk about charge, mostly electrical charge, there are two types, basically two types. We have what we call positively charged, as positively charged body, positively charged body, and we have what we call negatively charged body. Negatively charged body. I'm just forming it. Charged body. So what do we mean by that? When do a body said to be positively charged? When do a body said to be negatively charged? Very important. Remember, a positively charged body is a body that has excess of protons as compared to its electron. As like I say, a body is charged with a particular type of charge that is in excess. A body is said to be charged with a particular type of charge that is in excess. So charge is all about electron imbalance. So a positively charged body is a body that has excess of what? Protons as compared
All right, you can see that the early Greeks know that amber, after when it has been rubbed, can pick other tiny objects. So that means without that rubbing, there won't be any possibility of it picking another body. So with this, you see, rubbing is the process of what? Electrifying. That is why he said it is this rubbing that enables what? Amber to acquire electric charge, which make it possible for you to attract small objects. Then we see that it's not just limited to amber. We're going to see something like ebonite rod. That is the same thing as what they call plastic rods. Plus what? Four. Now I want you to understand something here, very important. Ebonite, when you rub ebonite with four, ebonite with four. We see that four lose electron to ebonite. I know when a body loses electron, it's said to be positively charged. And anybody that gain that same equal magnitude of this thing, the charge, is said to be what? Negatively charged. So electron imbalance is what charge is all about. So what is transferred is electron, and it is the level of electron in an atom that shows whether it's positively charged, negatively charged, or neutral. If electron in an atom is less than proton, then a body is said to be positively charged. If electron in an atom is greater than proton, then a body is said to be, you know, negatively charged. If electron in an atom is equal to proton in that same atom, then a body is said to be neutral. So you should take note of that. So because of this, four lose electron. There is electron transfer to this ebonite or plastic rod. With that, the four is said to be what? Positively charged. Positively. Positively charged. Don't forget, that is what any exam would like you to. So I know, you see, why the ebonite is said to be negatively charged. What make the four positively charged and what make the ebonite negatively charged? Because the four lose electron. Like when we come to metals and non-metal, we know metal to be good electron donor, and that is why they stand a chance to form cations, positively charged ions, and non-metal to be good electron acceptor, and that's why they stand a chance to form a negatively charged anion and all that, negatively charged ion. So you see, another example is when you have your grass rod plus grass rod and plus silk. So grass rod plus silk. So with this, you see grass rod at the end will become positively charged. Positively charged. Why? Because you lose electron to the silk. Why the silk become negatively charged? Negatively charged. Don't forget that. And again, at times they can use something like cellul like polythene plus woolen clothes, woolen uh, clothes, woolen clothes, polythene plus woolen clothes. So I want you to understand that at the end, polythene is said to be negatively charged. Why the woolen cloth here is said to be what? Uh, uh, Positively charged. If you rub polythene and woolen clothes or woolen clothes. Then, but when there's what they call cellulose acetates, cellulose acetates plus maybe cotton cloth now, cellulose acetate plus cotton cloth or just any clothing material. Discover that instead this one this time around is the one you are the one that lose electron. Here you are the one that lose that electron. Why this one gain? That's why you gaining electron make you negatively charged. Why you losing positively charged? But here the reverse. You see, cellulose acetate lose electron to making the cellulose acetate positively charged. Why the cotton coat or whatever clothing material that you use is negatively charged. All these are what you need to know. Master their polarity. It is very important.